Okay, so now that we have a little bit of understanding of how those three characteristics help describe our quadratic functions, now let's just kind of get into some more details that we just discovered. So our last example, where we had the shift and the orientation upside down and all that good stuff, that was a quadratic function in standard form. And so standard form is a nice form for your quadratic functions because you can pull out that information pretty quickly. So let's generalize it. So we might have some stretching going on or not. So we'll denote that with the letter A. And then we have our H and K here. So because it's a minus, we know it's shifted to the right H units and it's shifted up K units. So that's going to give us our vertex. So the vertex will be of the form HK. And we also know that the vertical line x equals A should be our axis of symmetry. And then when A is positive, we know it opens up. And when A is negative, we know it opens down. So nice conclusions for all those things. So very nice when it's in this format. So the million-dollar question is, what happens when it's not? So what do we do? Well, we can tackle it a couple of different ways. So one way that we could, analyze our quadratic functions is to put it into that form. So if we have something that looks like this, how do we put it into a form that looks like this? And then that is going to be done by completing the square. So let's see how to do that. Okay. So if we have our function here, quadratic function, so the first thing we want to do is we want to try to get something that looks like this x minus h squared component. So that is something we're going to need to do. So here's the way I would recommend. So you want the first two parts of it there, but then I would leave a space, a blank. Add the one that's there, and then put another blank. So you're going to have two blanks in there for a reason. So the first blank is because you want to complete the square. You want to make this so that way you can factor it and have it as a quantity squared. So the question is what goes in this first blank? And how you determine that is based on this middle number. So because this is a 4, the rule is you want to take half and square it. So half of that middle number and then square it. So we can do that pretty quick. So half of 4 is 2, 2 squared is 4. So I'm going to add 4 in this blank. But you don't want to unbalance your equation. You've added 4 to one side of the equation, you need to fix it. So the way to fix it is to subtract the 4 in the second one. So you've added 4 and subtracted 4 so they cancel each other out, so you're not changing anything, really. But now we can do a little bit of rewriting. So this trinomial is a perfect square now. So we should be able to factor it into something that looks like this. So we should have x, and then we have, again, a blank based off of these numbers. So now the question is what goes here? Well, the half part is what goes in there. So when you take this number and cut it in half, that's the number that's going to go in here. So in this case, we want the plus 2. Now we're going to verify this in just a second, but let me just finish it up. So we have that part which takes care of this trinomial. And so the last part of it is just to combine these two numbers. So 1 minus 4 is a minus 3. And so that should be your answer. Now, again, if you're not sure if you did it right, let's multiply it out. So if we take x plus 2 and multiplied it by itself, we should get x squared plus 4x plus 4. That's what we want. And we can check that pretty quick by foiling. And so we do get x squared plus 4x plus 4. So now it's in standard form. So now we have all the information we need to graph this. So what can you tell me about the vertex? Where's the vertex? So +2 means it shifted to the left, and the -3 means it shifted down. So the vertex we know is -2, -3. So that's in quadrant 3. So again, this is just a rough sketch. We're not going to get too crazy detailed. But because it's in the third quadrant, let's focus our graph on the third quadrant. So 1, 2, 1, 2, 3. So boom, there should be our vertex. Now, again, we could get a little bit, be a little bit careful about where it crosses the x-axis if we wanted to. But the big thing is that it's going to cross somewhere between 0 and -1 and -3 and -4. Somewhere in there. So it should look something like this. Now another nice little trick with parabolas is the 1, 3, 5 scenario. Once you know where the vertex is, to get more points on your parabola, you can go over 1, up 1. So there's the 1. But to get to the next point, you want to go over 1 and up 3. So over 1, up 1, over 1, up 3, over 1, up 5 would get you to the next point on your parabola. And you can do that on either side. So it's a nice little trick to be able to draw them by hand. You know, obviously calculators and all that stuff can do it too, but when you're drawing it by hand, it's just a nice little way to get to it. So 1, 3, 5. 1, 3, 5, 7, 9. You can do that forever to get a huge graph. So that's that. All right, let's try one more. It's a little bit tougher looking, but we can complete the square on this. Even though it's got this 3 in the front, we still have ways to do it. So let's see how we can do that. So the first thing, very similar to what we did up above, we want to get some blanks in there. So we got 3x squared minus 12x blank plus the 1 and then another blank. So now the question is what do we put in here to do this? Now here's where it gets a little messy because of this 3. We have to get rid of this 3 before we can really complete the square. So what you should do is factor the 3 out of these two terms. So we're going to have a 3, our parentheses, our minus 4x, and then our blank. Now again, these aren't the same blanks per se, but we're going to put it all together here in a second. So we don't like to have that number glued to the x squared, so that's why we factored it out. So we're going to see some more of these as we go, so don't fret. And so now we have all that. Now this one's a nice one because it's a 4 again, so we already know that this should be a plus 4. If we take half of -4, which is -2, and then square it, we get a positive 4. But do we want to subtract 4 here? Yeah? That's a big no. And the reason why is because of these parentheses. We didn't add 4 here. Truthfully, what did we really add? This 3 outside is going to modify that 4. So we're not adding 4 here, we're actually adding 12. So that's technically what's happening up here, is that we're adding 12. So if we're adding 12, we have to subtract 12. So we're going to subtract 12 down here as well. And so now we can keep going. So this is a perfect trinomial, perfect square trinomial, so we can factor that. And what did we say before? Whatever we took half of, that's what goes here. So we took half of -4, which is -2. So -2 is what should go here. And now 1 minus 12 is -11. And so that should be our quadratic function in standard form. And so now to answer the question, the vertex better be shifted to the right and shifted down. So 2, -11. So that should be it. Now, if you don't like completing the square, I'm going to show you another way you can do these problems in the next video. So see you soon.